So very good morning to all of you. Today our 51, 51 lecture on fluid mechanics. So yesterday we have started the unit number 6, that is on the gradually varied flow. So we have seen first the flow and classification of flow, steady and steady, and in steady flow, uniform and non-uniform flow, and non-uniform flow, gradually varied GVF, and rapidly varied flow RVF. We have seen the figure also, the locations of uniform flow, gradually varied flow, rapidly varied flow in the open channel. Okay, and then we have discussed many times the laminar transition and turbulent flow based on the Reynolds numbers, and non-uniform flow, the velocity of flow and depth of flow if remain constant, that is the uniform flow, and if that velocity of flow and depth of flow is changing as the flow progresses, then that is the non-uniform flow. In that non-uniform flow, the gradually varied flow, if the depth and velocity changes gradually, it is called as gradually varied flow. And if the flow that involves rapid changes in the flow depth and the velocity, it is called as rapidly varied flow. The known geometrical dimension, if we have, then that channels, open channels are called as prismatic channels, and if irregular cross sections are there, then that type of channels are called as non-prismatic channels. Then we draw the dynamic equation for the gradually varied flow, and this is the general, this is the figure based on that. The river approaching the obstruction here is the dam, okay, and based on the two section we have taken, we have derived the this our gradually varied flow dynamic equation, that is dy by dx is equal to S0 minus Sf divided by 1 minus q squared t divided by GAQ, where you know that S0 is the bed slope, Sf is the energy line slope, and Q is the discharge which is constant, T is the top width of the channel, G is the acceleration due to gravity, and A is the cross section area for the non-prismatic channel in this case. Okay, so this dynamic equation for the gradually added flow we have seen yesterday, and I have given the number 2 for this equation is the dynamic equation. Now here one thing you should note that please I will request all of you, simultaneously I'm speaking, you should write, okay, try to write on your notebook also, or try to understand also. Okay, don't play with the pens and pencils, okay, or put the mobile aside. Okay, so at the end of the lecture your attendance will be marked and I will call your names. Okay, so this equation, dynamic equation, you will note that it is assumed that depth of flow y is decreasing. So today is our 51st lecture. So dynamic equation, that is, sorry, dynamic equation, yesterday we have derived this dynamic equation, that is, many students they are joining late. I request them to join on time. There should not be disturbance. Okay, so this dynamic equation yesterday we have derived dy by dx is equal to S0 slope of bed, Sf the slope of your surface our energy gradient, total energy gradient, SF, due to friction. And this Q square is the discharge which is constant, and T is the top width of the channel, G is the acceleration due to gravity, and A is the cross section area. So this we have derived this dynamic equation for gradually varied flow yesterday. Okay, so the note you can write down for this equation. It is assumed that assumed that assumed that assumed that depth of flow depth of flow depth of flow y decreasing decreasing in direction of in direction of flow in direction of flow is negative. If depth of flow is decreasing, it means that the negative in the direction of flow, and that if it is increasing, the depth of flow, if it is increasing in the direction of flow, so that is considered to be direction of flow is positive. So this positive and negative because of increasing decreasing values of depth, okay, in case of your open channel. Okay, so this we have dynamic equation for the non-prismatic channel we have derived yesterday. And for the rectangular channel, the dynamic equation for the rectangular channel, you can write down for rectangular channel. The dynamic equation will be dy by dx is equal to S0 in large bracket, then 1 minus small bracket yn upon y to the power of q divided by 1 minus and small bracket yc upon y to the power of q. This is the equation for the wide rectangular channel. I will say some equation number 4. Similarly, for the rectangular channel, dy by dx is equal to dy by dx is nothing but the slope of your flow, the depth, 1 minus f square. This is the equation number 3. If I write down this equation number 3 is dynamic equation for rectangular channel. Sorry, sometimes the pen they are not working. Channel, or sometimes it is the fault that happen. Okay. Now for the trapezoidal, circular channel or triangular channel, the general equation, if we have to consider by using the convenience factor and the section factor. So first we see this, what is the convenience factor, that we are denoting the convenience factor with respect to k. K is the convenience factor, and the equation for definition for the convenience factor, k is equal to AC under root of R. AC under root of R. This is the convenience factor. Okay, so you can write down this, so that Q is the average constant, so that the Q, that is discharge, is constant, and it can be written as, the formula for Q is equal to A into V, and it can be written as C A. C is the change is constant, A is the cross section, under root of R into R into S. But you know that the CA under root of R is nothing but the value of K. So if I write the discharge in terms of the conveyance factor, Q is equal to K times under root of S. Okay? So we can write down like this. Okay? And if the K is equal to Kn, yani depth, actual depth is equal to, first you should know that Y is the actual depth of flow. This you should remember. In derivation already explained, but I will once again say to you, YC is the critical depth of flow when Froude number is 1, and YN is the depth of flow. So these three depth of flows we are considering here. The value of K is which it is here for the actual depth of flow. If you write in depth of flow Yn, so if you say that K is equal to Kn, it means that the slope S is equal to S0, that is S0 is the bed slope. S0 is the slope of bed of channel. Okay, slope of bed of channel. Okay, so here if you write down, so what will be the equation now? That the Q is equal to K times under root of S0, and if flow is non-uniform means the depth and velocity both they are changing with respect to the flow. That S is equal to SF. So you can write down Q is equal to K under root of SF. If we equate the discharge, because discharge is constant, so K under root of SF is equal to Kn under root of S0. So if I will write down in terms of SF and S0, under root of SF upon, I will take this here, it will become in the denominator, the S0, and then this is numerator in Kn, then K will come at the denominator here. Okay? So if I will write down this, so SF upon S0, if I leave the under root, so what will be here? Kn square upon K square. Am I right? This is the value of SF upon S0 is the Kn square upon K square, or I can write down in bracket Kn upon K whole bracket square. Okay? This is was the conveyance factor, and you know the section factor Z. Section factor is denoted by the Z, and by definition it is nothing but under root of A cube upon T. Under root of A cube upon T. So if I will write on this Z square, so Z square अगर मैं लिखता हूँ तो it will be A cube upon 2, and that root will be removed. And for critical condition, So ZC square is equal to Q square upon G is equal to AC cube upon T. This is for critical condition or critical flow. Critical condition, or you can say that for the critical flow, the section factor. And if not critical flow, then Z section factor Z square is equal to A cube upon T is for non-critical flow, critical flow, or non-critical condition, or non-critical condition. Okay. For non-critical condition, Z square is equal to A cube upon T. We will remove the underscore. The equation 2 can also be written as written as that equation Q can also be written as Q is T upon A cube is nothing but section factor, or Q square upon T, just Q square upon T. First we write Q square upon T is nothing but this, Q square T upon GA cube is nothing but the ratio of ZC square upon Z square. Okay. So here in place of equation number 2, Q square T upon G A cube, we can write down ZC upon Z. Okay. So this will be, it can be written as dy by dx is equal to S0 in bracket 1 minus small bracket Kn upon K whole square divided by 1 minus Zc upon Z whole square. Okay. Z square is A cube upon T, and Zc upon Z square is Q square T upon G A cube. So that we can say the equation number 5, and this equation number 5 can be used, equation 5 can be used for used with more ease of calculation for trapezoidal triangular and circular sections. So it can be used easily, this equation number 5, for the trapezoidal and other triangular and circular sections. Okay. So this is the, you can say, the generalized equation for this and can be used. This is nothing but all these equations what we have seen today till now. I will change the color. This is the, just we have derived this equation for non-prismatic channel when geometric is not defined. Okay. Then you can come to the white rectangular channel. This is the equation for the white rectangular channel. This is the equation for the rectangular channel, and this is equation for the trapezoidal, triangular, and this equation is for trapezoidal, triangular, and circular channels. Okay. So these are nothing but the dynamic equation to find out the slope or profile of your water when the gradually valued flow is there. Okay. So these equation help to find out the profile or to make the profile of your flow in case of the open channel. Okay. Now we will come the section. Second topic of today's outcome is nothing but you have to sorry you have to find out the surface profile surface profile in wide wide rectangular channel rectangular channel. What is the surface flow? The top layer or top level of the your water or any liquid that is flowing, uh, making the profile with respect to their flow and with respect to the slope of bed with respect to the total energy gradient line. If you are drawing the profile uh, in case of any type of channel, that is called as surface profile. So surface profile, how you will make the surface profile, that we will see here. So here some terminology for the slope of bed we can use. If the slope of bed is mild, so we will say that mild slope and it is denoted by M. Okay, and if the slope of bed is steep, then that is we are called as the steep slope. Yani slope is large. Okay, and if the slope of bed is critical, so we will say that critical slope. And if your bed is horizontal, so we will say it as a horizontal. And if your bed of slope is reverse, so we will call is at adverse slope. Adverse slope. Okay. So, so it is the slope is opposing the direction of the flow here. But in case of this another type, this is the bed slope, mild slope in the direction of flow. This one is the steep slope. If the slope is large, the angle making with the horizontal is large, and that is a steep slope. Critical slope, when your yc is equal to y, this is the critical slope. In between the mild and steep slope, and then horizontal slope if your bed is horizontal, and adverse slope if your slope is opposing. So this is the type of slope, and based on the types of slope, the profile of your flow is changing. The profile of your flow is changing. Okay, so this terminology, some terminology you should know. And again, once again, I will say you that you should remember that S0 is the slope of bed, and this is based on the slope of bed. These are classified. Okay, these are classified. Okay, the students they just want to come for attendance. I will request them please not join, disturbing the class every day. So here you can say the mild slope, the S0 based on the S0 is S0 is the slope of bed. SF is the you can say the slope of total energy line TEL, and S is the slope. Okay, if critical slope अगर हम बोलेंगे तो it will be SC, mild slope, maybe I will denote by SM, steep slope, I will denote by SS, horizontal slope, maybe I will denote by SH, adverse slope, I will denote by SA. समझ में आया? तो based on the conditions, you can decide slope of bed. Okay, so that is how we have to make the surface profile. Uh, we will learn here how to make the surface profile. So first we will take the mild slope in case of channel. So in case of channel, we will consider the mild slope. So to find out the surface profile, so we are using the equation for the wide rectangular channel. For the wide rectangular channel, the dynamic equation we know, the dy by dx is equal to s0 1 minus yn upon y whole bracket cube, similarly 1 minus yc upon y bracket cube. This is the dynamic equation for the, and this is based on the Chase's formula. This is based on the Chase's formula. Okay, and if you use the Mining's formula, if we use Mining's formula, so in that case, this equation, dynamic equation for the gradually varied flow will be, that is 1 minus yn upon y to the power of 10 by 3 divided by 1 minus yc upon y to the power of 3. So this only difference, and I will say this equation number 6. In this equation number already we have given wide rectangular channel. I think so. This is equation number 3. I think so. Here it is written. No, equation number 4. I think so. For the wide rectangular channel, this is equation number 4. This one. Okay. Equation number 4. Okay. So we'll use that for making the fall slope. And here, first case, we are considering this. First case, we are considering the mild slope. The bed slope is mild. Okay. And for other case, you can draw. I will take one case only. So you can so I will go for about the slopes. First, we will go for mild slope. Okay. For mild slope, first mild slope, mild slope. To draw the figure, the slope will be mild, not too steep slope. Okay, and this is the YC, this is the YN. Okay, so this depth is YN, this depth is YC, and I will write down this slope. There is three zones. One, two, three zones are there. Okay. So for mild slope, the bed slope is less than the actual slope, and the yn, the depth of flow, is greater than the critical depth yc. So in case of mild slope, this condition should be satisfied. In case of wide slope, this condition should be satisfied. Similarly, if you go for the steep slope, okay, steep slope, it is represented by S, steep slope. Mild slope is represented by M. Mild slope, it is represented by capital M, and steep slope, it is represented by capital S. Okay. So here you can see for the steep slope, here if you draw the steep slope, the flow is very, this is the steep slope, slope is very steep. Here the actual depth is less than the critical depth. So this is now, it is the critical depth yc, and this is nothing but the yn, the depth. Okay. So here in case of the zone, I will mark 1, 2, 3. In case of steep slope, that S0 is greater than SC. The bed slope is greater than the slope of your water. Okay. And Yn is here less than Yc in case of steep slope. So these conditions will be there in case of steep slope are there. So thus we have following types of bed gradient defined in case of wide rectangular channel under slope. This is for steep slope, and third one, if I will write down, that is the critical slope. Critical slope. When will be the critical slope? It is denoted by capital C. There is only two zones. Why? Because this Yn is equal to Yc. Here Yn is equal to Yc. Okay? Depth of flow Yn is equal to the critical depth Yc. So in case of critical slope, the S0 bed slope is equal to SC. Okay? Slope of the curve. So this is the case in case of, but if the horizontal slope is there, the bed is horizontal, fourth case, if horizontal is there, in that case, horizontal slope, we are denoting this by H. This is the bed is horizontal, there is no slope. So here S0 is equal to 0 and Yn is nothing but infinity. Yn is 10 to infinity. Okay. And similarly for the adverse slope, which is denoted by the capital A, the slope is opposite to opposite the direction of flow, the direction of flow should be shown. Generally, we are showing direction of flow from left to right. Okay. So if adverse slope is there, then also the slope is negative. The S0, the value is negative. So that here yn it does not exist. Does not exist. Yn does not exist. Okay. So these are the conditions. These are the condition for the types of slope. So in Yn this does not exist, and thus we have C. M. C is the critical, M is the mild, S is the steep, H for horizontal, A for adverse type of slopes, and each type we can introduce zone of the flow such as zone 1, zone 2, zone 3 as shown in the figure. So all the figures you can see there is here how many zones? 1, 2, 3. Here 1, 2, 3 zone in steep slope and mild slope. But in case of critical slope, only two zones are there. This is 1 and 2. Okay. Third zone is not exist. And in case of critical slope also, zone 2 is absent because Yn is equal to Y3. Only three zones, one and 3, only two zones are exist. And similarly for horizontal and adverse slope, zone 1 is absent. So here only zone 2, and zone 3 will be there in case of horizontal slope. So if you see that in total this of the mild slope, there is three zone, 1, 2 and 3, and steep slope also three zones, 1, 2 and 3, and critical there is two zones only, zone 2 is absent, 1 and 3 will be there, and for the horizontal and adverse there are also two zones, and first zone 1 is absent, second and third is there. So for you can say that this is 3, this is 3, this is 2, H for 2, A for 2, so M, S, C, H, A. So you can say that there for all these cases total 12 zones are there. Okay. This is this about the before you are going to make a profile for any type of slope. These basics are conditions we have to follow, or it exists actually in case of open channel flow. Okay. So this is all about that, and then how to make the profile we will see. Uh, how to make the profile we will see in the next class. So I will just write down some formula for you, and then we will stop. So what we have seen the formulas till now, the first one is the dynamic equation. Dynamic equation. Write down the formulas. Dynamic equation for the gradually varied flow in non-prismatic channel. Non-prismatic means irregular channel. Non-prismatic means irregular channel. Non-prismatic channel it will be dy by dx is equal to S0 minus SF upon S0 minus SF upon 1 minus Q square T upon GAQ. This is the first equation. So this equation is very useful for solving the problem and for making the profile for the non-prismatic channel, profile of the flow. Okay, and here you know that SF is the slope of your total energy line, and SF dx is nothing but loss due to friction. You know that the terminology you should also know for solving the example. And S0 is the slope of bed. S0 or SO what you are saying is the slope of bed. It is nothing but Z1 minus Z2. Okay, and Q is the constant discharge, and that is constant. That is constant. Okay, that net discharge is not changing. T is the top width of your channel. T is the top width of channel, and G is the A is the cross section area of non-prismatic channel. Prismatic is there, the cross section area of the channel, and G is the acceleration due to gravity. G is the acceleration due to gravity. Acceleration due to gravity. Okay? So we also know the average velocity. Average velocity is nothing but the ratio of constant discharge to the area, cross section area, where you are using the measuring the velocity. Okay. Second dynamic equation for the rectangular channel equation for rectangular channel. This we have seen today, and the formula for this, I'm writing each formula because for solving the example in the examination you have to remember these formulas. Okay, if you know the basic diagram for the lecture के बाद 5 मिनट हो गए. Dynamic equation for rectangular channel dy by dx is 0 minus sf 1 minus f square. Now we will see that f square is nothing but is q square t upon GAQ. That this we have derived from the Froude number, and you know the Froude number is nothing but V upon under root of GY, and V is the average velocity. V is the average velocity. V is the average velocity. Okay. V is the average velocity. So this is for the rectangular channel, and then third we can see that third F is the Froude number, you know, huh? Third equation, dynamic equation for gradually varied flow in a wide rectangular channel. wide rectangular channel. Generally in practical we are using this because the B is much greater than the depth in case of this. Okay, the formula for this is dy by dx is equal to S0 cap big bracket then small bracket yn upon y cube and 1 minus yc upon y whole bracket cube small bracket and then capital bracket we will close. This is the equation for the dynamic equation for the wide rectangular channel, and all this terminology you know. All this terminology you know. And fourth one we have find out there's generalized dynamic equation, and that is dy by dx is equal to S0 and capital bracket 1 minus kn upon k. Kn is the convenience factor, that is k is equal to Ca under root of r, and r is the hydraulic mean depth. Okay, and Zc upon Z whole square. Okay, so this is the dynamic equations for the different types of geometry. This is for the triangular, this is for the trapezoidal, triangular this type, and trapezoidal or circular channel. So this is for the triangular, trapezoidal and circular channel. Okay, so these are the dynamic equations, and these equations are useful for solving the examples. So these are nothing but you have to remember, and based on this you can find out dy by dx is nothing but change in the your y depth, and that is nothing but slope of actual slope or profile of your water, how the water is gradually varying at different section you can say. So that's why that is dy by dx. So as the value of y and y changes, will your the values of profile of your water you can find out. Okay. So today Kalyani is there. Okay. I'm taking attendance. Hashim Ansari, Muhammad Abdullah,
Yes, sir.
okay. Tejas Muhammad,
Yes,
Yogita,
sir. Yes, sir.
Mumin Saif,
Yes, sir.
Mumin Saif,
Yes, sir.
Mumin Saif.